I'm Anil Kumar, and here is a very interesting example on factoring by difference of cube. So we are basically doing difference of cube. Example for us is factor x to the power of 6 minus y to the power of 6. Now this question is very interesting, and at times I've seen students asking one particular question, and that is, there are two ways to do it. We could treat this as x square whole cube minus y square whole cube, and we could also treat this as x cube whole square minus y cube whole square. Now the question is, out of these, both are correct, we know, which is a better method to apply? So with this video, I think you'll be able to appreciate which is a better method to apply in this particular case. So let me begin with the first one, which is x square whole cube minus y square whole cube. Now difference of cube formula, you remember, a cube minus b cube is a minus b. So in this case, a is x squared. So we can write this as x square minus y square, that is a minus b, times square of a, which is x to the power of 4, plus product of these two, which is x square y square plus square of the other term, which is y to the power of 4. Now x square minus y square could be further factored. That is difference of squares, and we could write this as x plus y times x minus y, and we already have that third factor as x to the power of 4 plus x square y square plus y to the power of 4. So that is how we can factor using the first method. Now let us factor the same thing using the second combination, and then we can compare which is a better way of doing it. Now here, what do we get? We get a square minus b square, which we could write this as a plus b times a minus b, right? So we could write this as a is x cube plus b is y cube times x cube minus y cube. So we could write it like this, correct? Now, both are sum of cubes and difference of cubes, so they can be further factored. So if you want to factor this, what do you get? You get x plus y times x square, we'll write x square later now. Okay, let's make it x square plus xy plus y square, and this factor will be x minus y times x square plus, this was minus in this case, and here the sign will be plus xy plus y square, right? Now you see, this is very different from the result you got here. If I combine, bring them together, it is kind of x plus y times x minus y. So they are same. But the third factor is combination of product of these two. Let me rewrite them. It is x square minus xy plus y square times x square plus xy plus y square. As you can appreciate, these two terms, when you multiply, you'll actually get that term, right? So from here, what we can say is that if you adopt this particular method, you actually get these four factors, and if you adopt the first method, you get these three factors. I do not recommend that if you get this, you try to go there, or if you get this factor, we may combine to that place. Well, in some multiple choice questions, we may be given one particular answer. So there you may have to match. But otherwise, at this stage, you can say that the factoring is complete for you. I hope that helps. Thank you and all the best. Now, as an added exercise, what you can prove is that x to the power of 4 plus x square y square plus y to the power of 4 is equal to x square minus xy plus y square times x square plus xy plus y square. So let that be an exercise for you to do, right? I hope that helps. Thank you and all the best. Now, here is a hint to do this question. Hint is that you can, if you are starting from left side, it could be done from both the sides. If you are starting from left side, you can treat this as, you can write this as, think like this, x to the power 4 plus, if I add and subtract x square y square, then what happens? See here, it is x square y square plus y to the power of 4. If I add x square y square and subtract x square y square, I get 2 x square y square, right? I could write this as x to the power of 4 plus 2 x square y square plus y to the power of 4 minus, let me write this as xy whole square. Now this is a perfect square, right? So I could write the left side as x square plus y square whole square minus xy whole square. This can be factored as x square plus y square plus xy times x square plus y square minus xy, which is same as your right side. Do you see that? So that becomes an interesting question to do, right? But in any case, in such a problem, what I recommend is that if you start from this side, leave it at this stage, and if you start from the other side, you may get 4 factors, which indeed is more factored than what you already had, but both are equally good, right? Now here is a new interesting question. You can prove that these factors, product of these and that, is same using the factoring which I've shown here. I hope that helps. Thank you and all the best.